Hello and welcome to today's lecture from High Water Studio. Today we're going to go off the beaten path a little bit from our normal tutorials and take a break from our FE review material. And we're going to dive into the world of Unity and creating some environmental engineering applications using the Unity software. So just a quick kind of rundown of what we're doing here. We basically are going to be using a couple of these valves, these pipes with valves that are interactable so that we can turn flow on and off using these valves. And then we're going to model the flow rate from the combination of flows from those valves and realistically model basically the volumetric flow rate into this tank here so that it fills up in a way that's realistic based on our volumetric flow rates that we've given them. Okay, so that's what we'll be doing today, and I hope you enjoy it. We'll just go ahead and dive right in. Alright, so obviously I've already set up our scene here, and on these, so I should give some shout out here to this here. These are actually the Cinti Studio Apocalypse Pack props for these pipe valves, pipe, and tank. Obviously this tank, I have it set to do a, here, set the rendering mode as transparent so that we can actually see the fluid inside. And yeah, that's about it. So I have my scripts started here, but I haven't actually really filled them out other than a little bit on the player controller, which is, we do have the regular FPS standard asset controller from Unity, but I'm going to be attaching to that this player controller onto the camera so that we can have a Raycaster, basically, is all this really does. So we'll use this for the Raycast to be able to interact with the valves. But let's go ahead and really, the rest of these are just blank. Let's go ahead and start, I think, with the valve controller, and then work our way forward to the player controller. So our valve controller here, what we're going to want to do is give it some overlay, some kind of UI overlay. So whenever we're looking at our valves, we get some player input that tells us that we can interact with that object and how we can interact with that object. And actually I have built this overlay already, and it's just a text overlay that says press E to open valve or F to close valve. And so that's what we're going to display to the player. And we're actually going to control the fluids using the fluid in the tank using the valve controller. So let's jump in and get going on that. So we have we know we're going to have a canvas. So if we do a serialized field of type canvas, and I'm going to call it overlay. And we know we're going to have a fluid that we're going to want to control, which is the fluid in the tank, right? And let's just, at least for now, have that as a game object. And so when we start, we're going to grab that overlay and turn it off. Oops. All right, that way we don't have the overlay in our face all the time. Obviously, we don't want that. We want it to start either on or off, obviously off. And then in our update, we're going to control when to display the update and how to handle player input based on the update or based on the overlay. So actually, I think what we'll do first is make a couple functions to control whether the overlay is on or off. Alright, so we got one to display it, one to hide it, and obviously we're going to be calling these from a different script, so we're going to want to make these public. We don't have any kind of return, so we just have a void on return. And so really we're just turning the overlay on and off by controlling whether it's enabled, right? Sure, you've probably done that before on multiple different things. And now let's look at what to do if the overlay is enabled. That means we are looking at something that's interactable. And right now all we have are the valves. So, and actually I'd like to be a little bit more explicit especially on tutorials. So a lot of times I'll say explicitly that it is true or false. And so if it is enabled, if it is enabled, then we're going to give him those choices. We give the player choices, or whoever is using it, whatever. And I was using, I was like, well, why did it do that? I was using E and F. So what we can do is say fluid, which is going to be our liquid in the tank, and on that we're going to have this fluid controller. And then we'll have a function to open the valve, and we'll pass through a flow rate based on the flow rate associated with the pipe on this valve. And if they use the other key command, get key down, key code .f, that is going to close it. Now you really wouldn't have to necessarily do this get component. You could just specify the fluid controller since we're doing a serialized field. But if you wanted to do something else later, then it might be worth it just to go ahead and set it up now as the game object, and then you wouldn't have to, you wouldn't be restricted. You'd be able to have all access to anything in that game object. Okay, so let's go ahead, before we do anything else, I think let's go ahead and create the serialized field for the flow rate. And I think I'm just going to use a default of 0.5. That way we have something if we don't put anything else on. And actually that's it for the valve controller. We don't need anything else, right? All we're going to do is tell it to, the valve's open or the valve's closed, and there's a flow rate flow rate associated with that pipe, and whether or not to have the UI active. All right, so let's jump over to our fluid controller, and let's see. So we got more to do here. This is probably the most involved part. So we're going to want to basically set up our dimensions for the tank and control its geometry and how it changes geometry over time. So let's start setting up for the dimensions of the tank. We can make these serializable so that they're exposed to the inspector in Unity, so we can modify these quickly and easily if we want to. So float diameter 7.5 F, that's what I have on the tank. Oh, yeah, it's going to give me errors. No. Oh, I guess that was actually the tank. The water in the tank was scaled to 7.5, so 7.5 units in X and Z. So I went ahead and just considered that as being a diameter of 7.5. And actually, you know, if you really wanted to try to make it very accurate, you could use the units, you know, define the units a little better than that. But it's hard to do when you're using assets, you know, that you've bought or something. And I also created a tank bottom, which I actually just used this little cube here, and I set the tank bottom as basically right here, and then a tank bottom and a tank top. Just using that cube to get the transforms for it. And so, as I mentioned, I also have a tank top. Just in time for summer. And, oops. There we go. Mesh renderer. So we're going to want to control the mesh renderer. This isn't a big deal, but even when something has no width or height, it can still cast a shadow, I've seen. So, whoops, not float. So I actually just turn the turn the mesh renderer off so that it doesn't, you know, show up at all. It doesn't cast a shadow. It doesn't do anything else. I have a hard time typing and talking at the same time. All right, so we are going to need to know what our flow rate is in different points throughout this script. So I'm going to go ahead and create something at the, you know, top level that we can use anywhere else. We can set it and adjust it as we need to. We're going to need an area. I'm just putting in 21 for just arbitrary reasons to have something there. And then the tank height. Again, I'll just put 0 for now. And that's all we really need to know, right? So we got the area, we got the tank height, bottom, top, diameter. We're going to set these, or adjust, you know, at least these are adjustable as necessary. I guess serializing tank height might be a good idea. Well, no, we got the top. Never mind. So yeah, no, we don't need to be able to adjust any of those. But we are going to need to start controlling things right when Unity loads, right from the beginning, right from the start. So our mesh renderer, let's get from our game object that this is attached to, which is going to be the fluid. We are going to get the component, mesh renderer, and just store that. And set it as false to begin with, because we're going to, at least in my example, how I have this set up, we're going to start with no, you know, the tank being empty. And then we can calculate the tank height. The area. Cast it to a float. get the exponent. So we're going to square square the radius, right? Pi r squared. And then we are going to set the local scale using a new vector 3 with the diameter, 0 height, and diameter again. So we're going to have a circle based on the diameter. And we're going to set the position using a new vector 3 at transform.position.x. So wherever you are in the x position. And then we're going to use the tank bottom. For our, setting it in the vertical. And then transform.position.z, so we won't be changing it in the z direction, which is of course not vertical, oddly enough, for Unity. And that's it. So we are going to basically set it as having no height at the bottom of the tank. We've calculated the tank height, the tank area, we've turned off its mesh renderer, and that's it. And cache the mesh renderer into the MR mesh renderer object. Now, let's see, what do we want to do? Let's before we do update, let's create our functions for controlling the flows. So our valves are going to control the flow, but this is probably not a good name for this because the fluid is not opening the valve. But once the valve is opened, we are going to start controlling the fluid based on the flow rate. That's why I named it that way. And so we have a flow rate, the really maybe, I don't know, growth rate maybe, or something, vertical height change might be better. But basically we're going to be taking the flow rate from the pipe based on the valve and adding that to the fluid. And that way if you have multiple valves opening, then it just adds to it. And then of course we're going to want to be able to do the opposite. So that when we close the valve, we're going to be subtracting away the flow rate. Whoops, not that, flow rate. And that way you can decrease the flow rate without going to zero. So if you have multiple valves, you close some of them, you can still have some flow rate instead of just saying you're at zero. And then I'm also, just to make sure things don't somehow go weird on me, I'm going to say if for some reason it's less than zero, then the flow rate is going to be zero. Alright, and I believe that is it for our... No, we haven't done the update. Sorry, forgot all about that. Okay, so this way we can control basically the growth of the fluid. Now let's start visualizing that. Actually, so we know the flow rate for the fluid. Let's start using it, basically. Let's make it, actually control the game object. So there's a couple of things we're going to want to control. Basically the scale and the position. That was probably pretty obvious. So first of all, let's check, let's turn on, because right now our mesh renderer is not on, right? So once we have given it some kind of depth, some kind of height, let's check that the mesh renderer is turned on, right? So if it's not on and we have a height, then let's turn it on. Okay. And do I want to start with that? Let's go ahead. Yeah, I'll go ahead and put this in. So just so that we don't have this thing growing forever, I'm going to go ahead and put in basically a stop when the tank is full. So we can do that by saying, oops, yep, transform dot local scale dot y. If it's less than half the tank height, oops, 0.5. Did I mess something up? There we go. If it's less than half the tank height, then you can adjust the scale. If it's you know, at or higher than the tank height, half the tank height, then don't adjust the scale. And so this kind of gets into one of the tricky bits of working with these volumes like this and adjusting them through scale, is that it's adjusted around its pivot, which is in the center of the cylinder. Now there are some ways to get around that, but not as far as I know if you're using just a regular cylinder, you know, primitive inside Unity. You'd have to basically use ProBuilder or, you know, Blender or something, whatever, some way that you can set the pivot differently. So in other words, that's why when this gets to half the tank height, the top of it is going to be at the top of the tank. And so as we grow this thing, we're going to need to adjust its position, its transform position as it's growing, and so that we keep the bottom of it in the same spot, because the bottom is growing down as the top is growing up. Okay, so let's do that. Let's do the scale first. And what I'll do is I'll add to that the new vector 3. And of course we don't want to do anything with the X position or the Z position or scale, but we do obviously want to adjust the Y, Y position. And the way we're going to do that is by dividing the flow rate by area. And so volumetric flow rates, you know, we need to put our volumetric flow rates in a type of length cubed per time. So in other words, like cubic feet per second, cubic meters per second. That way, if we divide the area out, what we have is a velocity, basically, right? If you have a volumetric flow rate, you divide out your area, you have a velocity. And the velocity in this case is going to be the rate at which the surface area is changing its Y position, right? It's how quickly it's growing up. That's the velocity of the surface area changing. And then that times area gives you your volume. So we can do that in terms of using Unity. Whoops. We can divide that out and then use delta time, so that way it actually puts it in terms of seconds. Otherwise, whoops, I'm missing one. Also, forgot about that. Still have our Z position there. Otherwise, it's going to be based on frame rate and not have any real sense of time scale. It's just going to be sort of randomly based on CPU speed, which obviously we don't want if we want to try to be realistic about this. Oop. Now that we've adjusted our scale, we need to come back and reset our position using a new vector 3 again. And so we don't want to change our X, but we do want to change it. We want to change our Y position based on the flow rate, which is actually going to be the velocity. So basically, the rate at which it's growing, we need to move it up. That way, that bottom, as that bottom moves down, as it grows down, it gets pushed up. Hopefully that makes sense. Or maybe try it without doing this and see what happens, and then I think it'll make more sense if it doesn't already. I think that's it on this one. So it's actually not really that complicated. The only thing we have left to do, unless I'm missing something, I certainly hope I'm not, is work with the Raycaster. So on the Raycaster, we need to create like a cache for the valve. And then, check if we've hit one or not. So let's create now. You'd probably want to do this differently if you're working with more than just this really simple example. But in this case, the only thing we're really going to be able to hit is going to be the valves or interact with that we care about. So we can just check if there's a valve controller. Now, I wonder if I should have shown some of this. So so basically we're going to have this ray coming out of our camera, right? So we're going to be checking to see if we're hitting things we can interact with, things that we care about. If we're not hitting them, we want to shut off our overlay, right? We don't want to be saying, press E to open a valve when we're not looking at a valve. So let's check if we're not hitting something. If our object hit being returned is null because we're not finding a valve controller, then if our valve is not null, which has to do with basically we've seen it before, so now we've stored something in valve up here. Otherwise, this could be null and you'll get an error. Oops. And if our valve overlay is on, it's enabled. Then we can hide the overlay. So this goes back to here and shuts off the overlay. So that's such terrible terminology. I'm sorry, I shouldn't really be calling that a valve, but I did. And then get out, like bail from this update loop. Otherwise, you're going to start having problems, right? Because it's going to be trying to do this next thing, which is going to be if we do have an object hit. Let's set that to our object so we know which one we were just looking at, and turn on there we go, display overlay. I think that's it. Should we start it up, see how many errors we have? Well, there's one right off the bat. Oh, I haven't set these up, have I? So this is going to be, yeah, this needs the fluid, which is going to be in the tank. We have our water. We have our overlay. There's our overlay. So for our left and right valves, and does this have something? No. Is that it? I think so. Does this have something? No. Okay. Try that again. Alright, see now things are working better. When we get up here, when we interact with these valves, where we, raycast is colliding with the valves, you can see barely, I should have made that wider, but we have our open valve, closed valve. We look over here, we've got no fluids. Turn the valve on, we can see that the fluid is starting to fill up from the bottom, slowly filling up, and sorry, I got people talking to me. Okay, so, and then we can come over here, we can close the valve, and now the valve is closed, we're getting no more fluid flow. We can also try to close it down more, F, and nothing's happening. It's not going negative, it's not draining. So we can turn this one on. Oh, did I have a little bit of a bug there? Turn it on. I think I actually turned it on twice. Yeah, I did. So, because it's still flowing up, and if I turn the other one on, now it's. Oh, I'm hitting F. Sorry, I don't know what I'm doing right now at the moment. All right, so E. It's on. E. Now it's going twice as fast, and it should stop once it gets to the top. And I haven't timed this, but the seconds it takes to fill this tank up should be, if you multiply the area by the height and divide it by the volumetric flow rate. Yeah, see, no, that's interesting. Oh, I think because, I'm actually not sure why that was sticking like that. Then you should get the number of seconds it takes to fill the tank up, and it should be working out. Now, the one thing that is definitely an unfinished part of the code is that you can actually keep opening the same tank over and over, or the same valve over and over, and adding to your flow rate. And the reason that is because of the way that sometimes it's like, I'm not sure why. So the reason for that is because the booleans are static, so you can't just say a valve is open or closed. It would apply to all your valves. So if you're going to have more than one valve, you're kind of stuck there, unless, I guess, if you created like a dictionary and mapped individual valves inside this dictionary and then had booleans for each valve, that would probably be the way to, control whether each valve is actually open or closed, or even partially open or closed. Okay, though, I think that's it for this tutorial on Unity. Hopefully it wasn't super long. I actually wasn't timing how long this took. I think in our next one, we might put in a drain here, and that's actually going to be very different. One thing about this flow rate is that it's volumetric flow rate with constant head. So basically our flow rate is not changing at all during the course of this tank filling up. And that's a reasonable assumption, I think, when you have like a city, municipal distribution system supplying your flow, because it's going to stay relatively constant, and you have this reasonably small tank here. Now, when you have a drain, unless you have flow coming in at the same rate as it's draining, you're going to have a falling head condition where as this surface elevation drops, you have less pressure, so you have less drainage flow, and so you have to basically recalculate the flow as it's draining, so basically differential equation. So I think that's going to be our next one, but thank you very much for joining us on this one. I hope it was interesting to you and not super long and droning on forever. If you're interested in seeing our next video, a subscription would super help us out a lot, or a comment if there's something else you'd like to see. Otherwise, thanks for joining us today.